Hi there, I am Nick Fragelli. I'm a Senior Solutions Architect here at NetFoundry, and I am going to be showing you the magic of Ziti built in with the NetFoundry Ziti SDK into an open source project called SSH. SSH is pretty ubiquitous. If you've worked with any machine in a virtual environment, you probably know SSH. SSH is a mechanism for logging in using a secure shell. It's in the name. And it allows you to securely, quote, quote, access a server no matter where it is. But here's the thing about SSH. It's application-based security. Network security is trusted prior. And then application-based security in SSH kicks in where you identify yourself to the server, and that's how the server knows you are who you are. It then sends data from you, the client, to the server, encrypted at the application layer. There's a mediation layer in there too. But the network layer is unknown. Truly, the identity of the thing that did the connecting is unknown. So in comes VPNs. VPNs are installed into the operating system and give the operating system the ability to access a device or network of devices. And it does so by identifying the device to the server that it's connecting to at the network layer. Well, the problem with this is you still have to have something listening on the open internet or wherever you are. So that server still has to be waiting publicly or privately. It's listening somewhere for connection inbound. Well, inherently, there are ways to get around security. So if we take a look at this image right here on the left and the right-hand side, on the left-hand side is your traditional connection using SSH. You got a device, and we're going to use the internet as an example. A device on the left-hand side connects over the internet and the myriad of routings that occur on the internet to something that is listening, usually a firewall, which does forwarding whenever it sees a destination port bound for its public IP. And it forwards port, in this case 22, which is common for SSH, to some listening server which is running SSH daemon inside of its network. Well, do you see the problem with that? It means that basically this port is open on the internet. Somebody could sniff it, find it, and they could abuse it. Even if they don't have access to the machine using a username and password, passwordless without a key or with a key, they still know how to find that open port. And we want to get rid of this. So on the right-hand side, you'll notice that the change is that there's a network of routing that occurs that is customer-owned or NetFoundry-owned or a blend of both that the devices register and connect to first. And then there's a proxy mechanism that directs their traffic in the cloud towards a server that's listening in the same way. It connects in the same way. So everything connects outbound from its local network through its firewalls, whatever it is, connects to this routing mechanism in the cloud, which is designed to be ephemeral. You can take it down, it'll pop back up. It's like whack-a-mole. And then rules are applied to that access. So we can say that only the device on the bottom left and the right-hand side, this guy, is able to access this service, which is port 22 on this machine right here. And what's cool about this is no more open ports. So the firewall now can stop listening. It can stop forwarding, which means that nobody really knows how to abuse that service if the service exists. And the firewall doesn't have to keep track of all sorts of things like DOS protection. Okay, but that describes a VPN. Effectively, just moved to the cloud. Let's take it a step further. Where NetFoundry goes in the next generation of connectivity is with its SDK. So traditionally, you would have some sort of agent, an agent that is installed on the operating system of the device. And that agent is what does all the work for the applications of that device. And there are ways to manipulate how that VPN agent works. But ultimately, it is another application that simply captures traffic Instead of it going to the internet, it captures traffic going towards a destination and reroutes it over the VPN tunnel. Where the SDK comes in here is that when built into an application, the identity, the agent processes actually meld in with the application. So that means that no other application in the operating system, running in RAM, running off the disk, launched dynamically, can utilize the agent, which is another application, to gain access to that private resource. So we ultimately push the edge all the way to the application. Now we can hybridize. You can have a blend of multiple applications and an agent on the system through our tunneling mechanism. And the way that we're going to be showing SSH in this demo is that SSH daemon is going to be front-ended with a tunneling mechanism, your traditional tunneling mechanism, with our SDK built into it. But on the other side, zssh, the open source client, will have the Ziti SDK built into it, in this case, Golang. So Golang SSH, an open source project, is going to be compiled, wrapped around with the Ziti SDK. Instead of SSHing from a client with an IP address towards a destination server, we now SSH to the identity of the service that we want to connect to. That's the big difference here. Okay, so first things first, we have to get the open source project. So let's take a look at some links here. First is OpenZiti. OpenZiti, which is this right here. You can go to github.com, OpenZiti, and all the links will be available. You'll see all the projects, including the SDKs and the tunneling applications which make use of the SDKs, freely available, openly available. NetFoundry makes them openly available to anybody who wants to review the code. We've taken it a step further. We started to build a marketplace of applications which we hope will grow. In addition to our customers privatizing the SDK in their own uses, we've taken open source projects and Zitified them. One of those is what we're talking about today, Ziti SSH. So in the test kitchen, github.com, OpenZiti test kitchen, is the zssh client. Now keep in mind, the SSH open source client is the one that has the SDK in it. And although we could put the SDK also into the SSH daemon at the other end, in this case, we chose not to show you the hybridization capabilities. You could obviously do that if you wanted to, and then you'd have true zero trust connections where, simply put, there is no IPs. IPs are gone. Identities rule. I want to address and access something. I'm going to send it bytes, and the overlay does all the work of IP addressing and routing. So you have to first copy this down. You have to get the project and copy it down with Git. And I've already done that. So I did a git clone, and it produced the ZSSH source code on my computer. Now, of course, you can freely download. We've already pre-compiled for all the major operating systems, but if you wanted to, you could obviously build it yourself. You can look into the application and see how the code works. I've already compiled it, but I pulled it down source code based and compiled it using Go. So to take a look at that, this is what was produced, and that is linking to the open source projects from SSH, as well as other things with our wrapper, the SDK, to produce that ZSSH binary you see there. Aha, there it is. So this is no different than calling SSH. A little bit different front end because not all the features are there, but we can build those features in as required and needed, or somebody else could take the project and do it as well. So very similar, except for now ZSSH takes remote username at target identity versus an IP address, destination IP address. Okay, so now that it's been compiled, I first have to get an identity. So you have to go to netfoundry.io, or you can go to nfconsole.io and you can sign up for a free NetFoundry console, which makes use of the OpenZiti project. And I've already set up a few things here. Namely, there are some things I'm not going to go over, like how the endpoints and routers are all set up. I'm just going to give you an overview of how the endpoints are enrolled and how I'm going to use ZSSH to access that service daemon, SSH daemon that exists in a data center. So to show you that, we first have to enroll an endpoint. Now, an endpoint to NetFoundry is an identity. So what we're going to do is we're going to take the console into adding an identity mode, and we're going to create an identity with simply a name. Let's put that name in here. So it's located in Denver. That's just where I run my application. ZSSH is the application to be run, and really important, remember, the identity is identifying a specific application running on a specific device. Not all applications across all the devices, and not a specific device. This is ZSSH running on my Mac. I'm going to give it an attribute. In this demo, I'm not going to be talking too much about the attributes, but this is an important thing. Attributes will link it to the services that we see later on. In this case, ZSSH. Now I've created the identity in the system. At this point, it's simply a pointer. I have to get that key, which is a JWT, and I have to use that key to enroll this application to make it an identity in the system. Once I do, this ZSSH will have its own certificate, private, public, which it shares with the service that's in the cloud, identifying this application to the cloud. So let's first enroll. We take that JWT that was downloaded, and it's going to be turned into a JSON. That JSON has all the certificate information, and the other side, which is the cloud system, is awaiting somebody to talk to it with that certificate, the private part of that certificate that it shared during the enrollment process. There's a lot of things that just happened there. But suffice to say, we use that identity that popped out, which is a JSON, to identify this application when it comes time to connect to the service. So the next thing we have to do is we have to set up the service. Now, I've already done this. There's two major things in order to get this working that you'll need to do, which you can automate, by the way, with APIs. I created an advanced service in our console, in the NetFoundry console. An advanced service is something that goes beyond the wizard, allows a developer to create some pretty cool things that the applications are allowed to do. In this case, what you're looking at, if we go down the left-hand side, the name of the service that will be provided, the attribute, which is important for linking it to an app WAN, the terminology for basically profiling a bunch of services that should be reachable by attribute. I do want to encrypt always, so that's always turned on. You can optionally turn it off. Now, it's important for your information to know that SSH is still doing its job in encrypting at the application. But now we also encrypt at the network. So double layer up. The host of the service is going to be a gateway or device that's running the NetFoundry Ziti SDK in tunnel mode in the Denver headquarters data center. And that's identified by yet another attribute. Down here, we specify edge routers, or those cloud routers that you saw before, which should be part of or participate as a fabric for allowing these things to connect together, the endpoints that need the access and the service provided by the endpoint that provides that access. And this is how they connect to one another. We say all of the edge routers in this network should be available to that to create a fabric, which is based on costing. Here's the fun bit over here. Now, we go beyond the wizard, which you see in the NetFoundry console, which is general servicing. And because this is a Ziti built-in SDK into an application, we specify it a little differently. Here, we're saying, I want to specify a host that binds using its identity. And all this will be available. There's loads of information about how you would set up this JSON to allow participation for the service. In this case, I've already pre-filled it. If you look here, you'll notice that I'm saying this service should provide access to the local host on port 22 if it's identified using its identity for the server that is also enrolled in the network. I want to identify that server by its NetFoundry Ziti identity, and that's how I will access it. And it will transport me using TCP to the local host on this port. Well, there we go. The next part, most important honestly, is what binds these things together. We need to create an app WAN. An app WAN is basically a profile of services allowing endpoints that need access to talk to services on endpoints that provide access. You can see here there's the attributes that we applied. So we say the service attribute was the one that we just created, or that you just saw, is the jump admin. That's the SSH service that has bind listening identity. And the endpoint attribute is those or things or apps or whatever using the SDK that should have access to that service or services. In this case, we say the Denver, Colorado ZSSH applications. If we look in the preview, we'll see that. There's that endpoint we just created, which is the ZSSH, SSH, Go language version of the SSH open source project with NetFoundry Ziti built into it. And here's the server that provides access to the SSH server, the daemon. Now that that's been created and we've linked them, all that's left to do is access. So recall, we'll go back to the picture real quick. What we're trying to do here is go from a computer with a specific application, SSH in this case, that is an identified application now that we've enrolled it, into the cloud system. And that cloud system, the other side, is also binding for the service. And it's linked using the app WAN. So we should be able to reach it. Next thing, the most fun part. Let's take a look at this command I just put in. In fact, I'll clear the screen for you. We'll put in the command. Let's break it down. We're going to tell zssh to use the configuration, the -c, for this JSON file. That's the identity that we created during enrollment. We're going to say the service that we're trying to connect to is the NetFoundry Jump Server Loopback SSH service. Well, there it is, right there. And we are going to connect, extra bit there, we're going to connect to this identity. So the nfadmin user at, you notice there's no IP here, at this identity. Well, this identity is simply an endpoint. If we take a look at that jump server, there it is right there. This is the identity that hosts that service that had that tag that you saw in the app WAN. And when I say go, we'll use a different user. We connect. What happened? Well, first thing, ZSSH said, hey, cloud system, based on my identity, my JSON file, I should be talking to you. And I have a private key. And my private key says you should have the public side of that private key. So I'm going to communicate with you using my private encryption. And you can communicate back with me bidirectionally in TLS with your private key. And I have your public key here located in my JSON file. So therefore we have bidirectional communication and it should all be encrypted. I've identified myself to you, Mr. Cloud. Mr. Cloud, you know who I am because I had an enrollment process. And I know who you are because I enrolled to you in the beginning as well. So now at the network level, we have security based on identity that is very, very strong. So the next thing that happens is the cloud says, okay, I see you're trying to connect to or create a session to a service, which is this guy right here, hosted by this guy right here, called this. And that is a valid service that you should be able to reach. So I'm going to log you in as root using the normal SSH mechanisms. And I'm going to transport your bytes all the way over to this guy, pop you out to the local host where the SSH daemon is listening on localhost port 22. Now, the interesting bit is this right here. That session was permitted to access 2 routers, which were part of that system. So potentially I could be using either one of these routers right here to access to that server. That server is connected to these routers as well. So the session binds me through the cloud to the service and into the SSH daemon server, where then ultimately I get access to that server here, like a normal SSH session. And there you have it. That's Ziti SSH. Ziti SSH, which is the NetFoundry Ziti Golang in this version, could be the C version or the Python version. We have many different SDKs out there to access an SSH daemon server securely, without ports, completely dark. Strong identity over the internet.